So this is part 6 of 8086 instruction set. We will be dealing with another arithmetic instruction that does BCD arithmetic. So the instruction is DAS, that is decimal adjust AL after subtraction. So we already did see DAA, that is decimal adjust AL after addition. So similarly, this instruction DAS decimal adjusts the contents of AL so that it may be in BCD format, packed BCD format after subtraction. Okay, so just like DAA, this DAS doesn't take operand, so it has to be issued immediately after the subtract instruction so that its desired effect may be reflected in AL contents. Okay, so let's take an example and see why is it required. Suppose that AL is having the BCD 73, okay, or the 73 coded as BCD, packed BCD. Then suppose BL is having 29 again in packed BCD format, and we are issuing subtract instruction in such a way that 29 is subtracted from 73. So let's see what we require and what we will get actually. So this is 73 represented in BCD format. You can see 7 over here in the upper nibble and 3 in the lower nibble. Then 29, you can see 2 in the upper nibble and 9 in the lower nibble. Then remember that subtract instruction is a binary subtraction instruction. So what happens is this 29 will be converted to its 2's complement format, and then addition will happen, right? Then the result we will get after subtract in AL will be this one. Okay, so actually when we do BCD subtraction, what we expect in the lower nibble over here is a 4, but actually we will get A, that is a 10 due to this binary subtraction. Then the upper nibble part, it is 4, so there is no problem over here. So we are having a problem with the lower nibble. Instead of getting the actual result 44, right? That is 44 in BCD format. When we do subtraction of these two BCD numbers, what we are actually getting is 4A. So this 4A has to be adjusted so that we will get 44 in BCD format. So what is the adjustment required? So that adjustment will be supplied by DAS. So let's see how the DAS algorithm works, or the DAS instruction works. So DAS instruction, it checks individually the lower nibble and the upper nibble and provides the corresponding adjustment. So if you would remember, for DAA, that is decimal adjust after addition, the correction that we did was we added 6 to individual nibbles, right? So here the correction required is just the opposite. We have to do subtraction by 6 in the individual nibbles. Okay, so first we are examining the lowermost nibble. So in order to extract the lowest nibble of AL, we will do this AND operation and we will check whether the lowest nibble is greater than 9. So if it is greater than 9, or if there is a borrow, see, as it is subtraction, here the auxiliary flag getting set indicates a borrow has happened due to the subtraction operation in the lowest nibble. So if a borrow has happened in the lowest nibble, what we have to do is we have to subtract 6 from the lowest nibble, right? And then we have to set the auxiliary flag as 1 to indicate that subtraction. Okay, then we are going to examine the highest nibble. So the highest nibble is examined in this way. If the overall value of AL is greater than 99h, right? It means that the highest nibble is greater than 99, is greater than 9. Okay, so what we have to do, we have to subtract 6 from the highest nibble. So that is done, right? And carry flag is set to indicate that. Then so let's explain, well, re-examine this example. So 73 minus 29, right? 73 is coded in BCD and 29 is coded in BCD. Expected result is 44. So what happens is the intermediate binary result for the lowest nibble is it's 10, it's greater than 9. So the lowest nibble needs correction. So the correction is subtraction by 6. So 10 minus 6, the result will be 4. Okay. Then considering the highest nibble is 4, it is less than 9, so there is no need of correction, so it is passed as it is. So the final result that we will get after the DAS, that is decimal adjust after subtraction correction, is 44, okay, which is the exact answer that we expect. Now let's consider another example. Suppose that AL is having 75 and BL is having 46, and we need to subtract 46 from 75. So what will happen? So 75 is represented in packed BCD format like this. So you have upper nibble as 7, then lower nibble as 5, then 46 in packed BCD, the upper nibble is 4, lower nibble is 6. Then upon subtraction, what happens is, as it is a binary subtraction, the lowest nibble is turned as F, right, or 15, and the highest nibble is 2. Okay, so what is the actual answer we expect? So actual answer is, in the lowest nibble we expect a 9, and in the highest nibble we expect 2. Okay, so as per the algorithm, we will examine the individual nibbles. So the lowest nibble is first examined, right, then the highest nibble. So we are going to examine the lowest nibble. So it is greater than 9. So what has to be done? We have to subtract 6 from the lowest nibble and leave the answer there. Okay, so 15 minus 6 will give us the answer 9. Then we will also check the highest nibble. So highest nibble is 2. So there is no need of correction. So the final answer that we will get after the DAS adjustment will be 29, which is the expected answer.